Just to briefly introduce myself, so I'm a software developer at Focusrite, so mostly specializing in C++. And I've worked on products for Focusrite, Innovation, and currently Amplify. I was also here last year where I gave a kind of tour of the software stack at Focusrite. And when I say here, what I really mean is sat in my second bedroom staring into a webcam. So it's really nice to be in a real room with real people. A little bit about this talk. So end-to-end testing is just one type of automated tests. So I'm going to talk about different types and different strategies that we can use for automated testing, and we'll see where end-to-end testing fits into that. I'm also going to talk about a specific problem that we had and how we solved it to add end-to-end testing to a JUCE application. And if that's something that you're interested in, then I'll talk about how you might be able to add end-to-end testing to your application. A couple of assumptions here. I'm going to assume that you're vaguely familiar with JUCE and C++. I won't go too deep, but a little bit of familiarity would be useful. I'm also going to assume that you're already sold on automated testing. So I'm not going to be singing the virtues of automated testing in general. Hopefully, we all agree that it saves rather than costs time, for example. So automated testing. This is a diagram that might be familiar to you. It's called the testing pyramid. And the pedants among us would like to point out that it's almost always represented as a triangle, not a pyramid, but we'll let them go. You might see these things with different names. So instead of integration, it might be called service or acceptance. And at the top, instead of end-to-end tests, they might be called unit tests or something like that. And I'll go into each of these layers in a bit more detail, but the idea is that at the bottom, we've got the tests that are closest to the code. So that's where we're going to have the most tests. And that's where we're kind of heavily isolating our tests to try and focus on one bit of code. And as we move up the pyramid, we're gradually kind of integrating more code until we get to the top where we're testing our whole system. And probably as we move up through those layers, we'll get fewer and fewer tests. So that's the idea behind the shape. And the boundaries, even though I've drawn it with a kind of solid line, the boundaries aren't quite as discrete as this. It's kind of more blurry, and the difference between an integration test and a unit test, for example, is quite subjective. So let's take a look at the bottom level, so unit tests. So these are probably the ones that we're most familiar with. And the idea with unit tests is that if we break our code down, we split it up into smaller and smaller pieces, individual little atoms of code, and each one of those is tested, isolated and tested. Then when we bring it all together, we're building a system out of tested code. So we're trying to isolate those individual units, and that's going to be difficult because they're going to depend on each other. So in that case, we'll have to use kind of dependency injection techniques, so maybe using mocks or stubs or spies. And clearly, in reality, just bringing together unit-tested code is not going to guarantee us a perfect system. It's all very well having the right Lego pieces, but if you build them into the wrong thing, that's not really what the user wants. So in order to check that these units have been put together properly, we go to the next level up, and that's integration tests. So whereas with unit tests, we're trying to isolate single units in kind of as small as possible, the idea with integration tests is that we're testing that they're collaborating together, those specific units. So those, rather than testing a single class or a single function, we'll be moving up to testing maybe a whole module or a group of modules together. Are they collaborating? Are they doing the right thing? So these types of tests are probably going to be more behavior focused. They might be written in a kind of BDD style, given when, then, that type of thing. And if we keep moving up, we get to the very top, and that is end-to-end tests. And that's what we're focusing on today. So the goal with end-to-end tests is that we're trying to test a complete application or a complete system in its deployed format in as close to real-world conditions as we can manage. And that's going to be something, a theme through this talk, as close to real-world conditions, because we are going to have to make some compromises along the way. And those decisions we make are going to affect how well-tested our system is. So yeah, rather than testing individual units or individual modules, we're testing the whole application or the whole system. So how do we choose between these different levels? Ideally, in a good system, we're going to have a little bit of all of them. But we need to look at this, the properties of each level. So with unit tests at the bottom, they're very isolated. So they're only testing a very small amount of code. And that means they're going to be really fast to run. They're going to be simple to write. And they're going to be cheaper because they're quicker to run. So if a well-written unit test fails, it should point you to almost exactly where the problem is in the code. Whereas if an end-to-end test fails, it's going to be harder to work out where it is because you've got your whole system running. Yeah, at the top, end-to-end tests, so we're kind of integrating everything. We've got our whole system there. And that's going to make it a lot slower because we have to start up and shut down our whole system every time. It also makes them much more complicated. If a test fails, where's the problem? And it also makes them more expensive. So the longer they take to run, it's going to be more expensive. So that would kind of make unit tests look better, right? But they're just different. The thing that we get with end-to-end tests is a level of confidence that we can't get with unit tests. So we know that our whole system is working. So if something's working in an end-to-end test, we can be pretty confident that by the time the user tries it, it's going to be working for them as well. So we want a bit of all of these. We want to mix and match based on the particular systems, and it's not going to be, there's not a kind of prescription for how you should split your tests up. But in saying that, in my experience, the bit that often gets neglected is the end-to-end tests. And that's the bit that we often leave out because it's really hard. So we were in that position a couple of years ago with Amplify Studio. So this is Amplify Studio. So it's a desktop app for Mac and Windows, and it's built using JUCE. And it makes extensive use of the Amplify Sounds content library. So it allows users to combine and record sounds in a kind of fun, safe, and creative way. So we were in a position where we had a reasonable amount of unit tests, decent coverage, but we were lacking that confidence that you get from really good end-to-end tests. And that meant if we wanted to do a release, we had to rely quite heavily on manual regression testing, which is kind of time-consuming and error-prone. So we wanted an end-to-end system that we could test this complete app as it runs like a user would. So what were our requirements? So we wanted to be able to remotely start the application. That's important. We want to start it from somewhere else. Then we want to be able to kind of poke and prod their application like a user would. So that might be clicking buttons in the user interface. It might be typing things into the keyboard or selecting things from a menu, for example. Then we need to be able to query what the user's looking at. Are they seeing the right thing? Is the app in the state that we expect it to be? Is this particular thing visible? Is it enabled? So if you write code that runs in a browser, for example, there's something called the document object model, which is kind of like a contract between the page and the browser, which says everything that the browser needs to render. So if we want to write end-to-end tests for a web page, it's kind of a little bit easier because we can just poke around in that DOM and see what's visible. And that means there's lots of frameworks off the shelf to support it. There's things like Cypress and Selenium. But with JUCE, all the application sees is a window. So how do we kind of dig into that to find out what the user's actually looking at? So then we need to shut down the application. That should be simple enough, and finally report the results of these tests. There were also some acceptance criteria that go along with it. So we want it to be able to run on continuous integration. So we use Circle CI, but the principles are pretty much the same with whatever you're using. It's probably going to be running on a virtual machine that we don't own, that's going to be spun up by someone else. It's probably got limited memory and CPU. It probably doesn't have a screen attached or really limited resolution. And it probably doesn't have any sound cards attached to it as well, which is going to be a challenge because we need an audio thread. We also want our end-to-end tests to be fast. So we know that end-to-end tests are going to be slower than unit tests, right? We accept that. But the whole point of automated tests in general is feedback. So we need feedback if we've made a change to our app that's going to cause problems. So the quicker we get that feedback, the quicker we can make changes, and the quicker we can do releases. We also want it to be reliable. So we said that we need that feedback. We also want to be able to trust that feedback. So if a test passes, we want to have confidence that the code is actually working. And if a test fails, we want to have confidence that there's actually a problem. And if there's too many false positives or false negatives, then we're just going to lose faith in the system and we won't really trust it anymore. So I said we want it to be as close to real-world conditions as is reasonable. So that means, we don't want a special version of the app that we build for testing. We want to be building the real app that then gets shipped to users. And we also want it to be non-invasive. So by that, I mean, we don't want to have to kind of rewrite our whole application just to support testing. We want it to work with what we've currently got. Just as an example, we don't want to have to subclass JUCE components so that all of our components are special components. We want it to be a regular component. And we have this thing as software developers that we're quite averse to adding test code into our application, code that's only there for testing. We have this kind of mindset that we only want to pay for what we use. But it's actually quite common in other industries. So if you open up some electronics, you'll probably find test points that are there just specifically for testing signals and voltages and that type of thing. And if you take your car to the garage, probably one of the first things they'll do is plug in a diagnostic terminal to work out what's going on. And if you're lucky enough to own a VW, then it's even smart enough to detect that its emissions are being tested and turn them off altogether. So what was our solution to this? It's actually very simple. So there's two parts to it. There's a C++ library that we build into our application. And there's also an NPM package that's written in TypeScript, and we use that as part of our tests. So on the left here, we've got a Mocha test runner. So Mocha it's just a JavaScript test framework that's built on top of Node.js. In reality, we could have used any test framework there. The fact that it's Mocha is not really that important, and we just use it to kind of discover tests and run them and give us nice output and that type of thing. And actually, I'll show you an example later where I'll be using a completely different framework altogether. So that launches our tests, and the tests do everything that we spoke about earlier. So we want them to launch the application. We want them to kind of poke and prod it, press keys, that type of thing. Then we want it to be able to query what state the app is in and maybe check that it's in the expected state. Then we want it to shut down the application and report the results. So they do that using this NPM package. This is the new bit that we've worked on. And that's what the tests use to kind of communicate with the app. So that NPM package, it opens up and it starts listening on a port. And then it launches the application and passes that port to the app. And then the app connects back to it to say, and then we've got this kind of connection between the two. And we can start sending, commands and receiving responses and receiving events and that type of thing. So you might be wondering, why did we choose to build this on Node and TypeScript? And in reality, we could have really chosen anything, any scripting language that can open a socket, which is kind of basically all of them. We chose Node and TypeScript because it's cross-platform, so we can run it on Mac and Windows. It's got first-class JSON support, so we use a lot of JSON in the app already, so it kind of made sense to keep going down that route. It's type-safe, so a lot of the developers working on the product are C++ developers, so if we have to work in an environment that's not type-safe, we go a bit crazy. There's also consistency with our backend code, so a lot of the services that Amplify Studio is built on are written in TypeScript, so it's just a bit more familiar. And finally, the async await syntax in JavaScript and TypeScript allows you to write kind of asynchronous code in a very synchronous way. And that's quite important because we want these tests to read like scripts, do this, do this, do this, and not to be worrying about, control logic and that type of thing. So we want them to read as if someone had just written a script. So I want to talk about some of the challenges that we'll have to overcome to make this work. So remember this point, we're trying to match the real world environment as close as possible. So these are the kind of compromises that we'll have to make along the way. So the first one is, how do you control the keyboard and mouse remotely? So, for good reason, most operating systems don't let you just take over the keyboard and mouse, kind of without some sort of special accessibility privileges or something. And we're running on CI, so we don't want to start messing around with that. So how's this going to work? So I want to give the example of clicking a button. So if we think about how it works in the normal case when a user does it, so they move their mouse, and the mouse is picked up by the operating system, and that's going to be passed on to JUCE, and JUCE is going to pass it to our button, hopefully, and then our button is going to trigger something in the app, from there. And if we think about the bit that we actually really want to test here, we can kind of introduce some trust along the way. So the first thing is we're going to trust that the user's mouse works correctly. So probably to some people's disappointment, we're not making mouse-moving robots here. We're also going to trust that the operating system works, because if someone's operating system stops processing mouse events, then there's bigger problems out there. And we're also going to trust that JUCE correctly handles mouse events. That's not the end-to-end process that we want. So the bit that we really want to test is that when our button is clicked, the right thing happens. So we're going to kind of inject our testing in here. So this is the way it works. So we've got our test, we've got the npm package that's in Typescript, we've got our C++ library, and we've got our button. So the test is going to say, I want to click on this button, please. The npm package is going to turn that into an event that's passed over the wire to the C++ library. The C++ library is then going to have to go and find that component. So it's going to call find component with ID. We can kind of, and that doesn't know about that component already. It needs to go out and see if it's there. So it's going to do that by looking through all of the windows that are currently on screen and try and find a component that matches this particular specification. And once it's found it, it can just deliver the click event directly to that button. And from then on, the rest of the system should behave as it normally does. After that, the C++ library can send a response back to the npm package to say, yeah, found it, that all worked. And that can then send control flow back to the test. And I said that this was written with async await, so that test will not continue the logic until it reaches that point there. So yeah, I hope you can see that this is a bit of a compromise on an ideal system. We're not fully end-to-end testing our application, but this gives us all the kind of speed and reliability that we need. So the next challenge is, how do we query the user interface? How do we find out what they're actually looking at? And it's possible to go down quite a deep and dark rabbit hole here, thinking about capturing what's on the screen or screenshotting components and comparing them to images. But we want these tests to be reliable, and we don't want our test to fail just because someone's changed the way our app looks. It shouldn't be a breaking change to change what our app looks like. So the process we follow here is almost exactly the same as for the button. So here we want to check if a component is visible. So our test is going to say, can I find out if this component is visible, please? Passing the ID of that component. That's going to be sent over the connection to the library, which is then going to find it in the same way. And then it's going to check if that particular component is showing. So just is showing means that it's visible and all of its parents are visible. So the user can actually see it, basically. And that's going to be the same. That's still going to work even on with a terrible resolution. Maybe something's actually scrolled off screen or something like that. But it's still going to kind of appear like it's showing, which is what we want. That's going to then send control flow back to the npm package and finally back to the test, which can then assert that it's in the correct state. So our next challenge is, how do we handle things like system dialogues, like a file chooser, where the user's going to open a file and try and choose a particular file. It's hard enough to control the JUCE user interface, and it's going to be even harder to take control of a system user interface. So it's kind of out of the question, really. So I want to give the example of opening a project. And here we're going to have to follow the same process where we have to introduce some layers of trust. So somewhere in our app, there's going to be something which is handling something from a menu which puts up a file chooser. So the user's just maybe clicked file open, for example. We're going to say to JUCE, can we have a file chooser, please? JUCE is then going to pass that to the operating system, say, can we have a file chooser, please? And that's going to go to give us a system file chooser where the user will then choose their file. And that's going to pass it all the way back to our menu handler, which is going to do something. And in our particular app, we use something called a message dispatcher. So that is kind of a centralized messaging system where you can just post a message in and it can get picked up somewhere else in the app. So again, if we think about this and the bits that we definitely trust, so we definitely trust the system file chooser, and we definitely trust the operating system. We're probably going to trust JUCE as well. There's a little bit of code in our menu handling, which is going to ask for a file chooser, and we'll probably have to trust that as well. So that means we can jump straight into this message dispatcher. If we can send a command over that channel to say, open a project, and we pass it the exact path of the project, that's as close as we can get, or as close as we want to get to simulating the user actually choosing to open a project. So what does this look like? So the test, this time, here the npm package and the C++ package, the C++ library are generic. So they're not tied to any particular app. So the concept of opening a project, they don't really know about. But they can just send generic commands. So here our test sends a command to say, open a project. And it's just going to be passed through. So the npm package is going to pass it down to the C++ library, which is then, there's also a mechanism we use to add a kind of custom handler. So you can add custom behavior for a specific application. So that's going to pass it on to the custom handler, which is going to handle it. That's going to dispatch the message. And then hopefully, from that point on, everything would be the same as if the user had actually done that. And then in the same way, control flow goes back all the way to the test, which can check that that project opened correctly. So the next challenge is, how do you stream audio? So I mentioned this is probably running on a virtual machine, and that is going to be heavily stripped down. There probably won't be any audio devices attached to it, and there probably aren't even any built-in audio devices. Right? There's nothing on that system that can give us an audio thread. And if there's no audio thread, we're kind of missing out on a huge amount of functionality in our app that we'd otherwise like to run. So our solution in this case is actually something that we do anyway. So if the user happens to have uninstalled all of their audio devices on their system for some reason, we kind of start a backup virtual audio device that just sits there running our audio thread at the normal rate. And this makes sure that anything that requires the audio thread, so that might be transport or metering or position notifications, anything like that, they can carry on running and they still work. So the last one is, how do you manage network requests? So Studio is a very online application. It goes off to fetch packs and images and samples. So how's this going to work, running on a virtual machine that we don't control? And this is probably the easiest of the lot because it actually works, right? Those virtual machines are fully online, so there's not a problem with going off and downloading things. The problem is that it's very slow, and we want these tests to be as fast as possible. So in this case, we actually add another little step to this, which is a mock API that runs, our entire API, but just serving up pre-baked content. So yeah, this is what our system looks like today. And it's been really useful for us. We've got over 100 tests that run before any code gets merged. And that's 100 times the app has started and shut down and done something that the user might do. And it just gives us that extra layer of confidence beyond basic unit and integration level tests. And if this is something that you might be interested in yourself, I'm pleased to say that you can try it for yourself. We've just open sourced the whole system and put it on GitHub. So there's two parts to it. There's a C++ library, which you can integrate into your app. And there's also an NPM package that you can use with any JavaScript or TypeScript-based kind of test framework. So I'm now going to make a sacrifice to the gods of live coding because I'd like to give you a quick demo to show you how it works. Let's see if I can do this. Okay. How is the size? Can you read that at the back? I'm going to take that as a yes. Okay, so what I've got here is a really basic JUCE application that I've written. If I just run it up. Come on, you can do it. There it is. Okay, so I have a window, and I've got two buttons and a label. At the moment, they don't do anything because we're going to do this in a vaguely test-driven way. And if I just quickly show you the code, so I've got an application here, and the application has a window, and the window has a component, and in my component, I've got my 2 buttons and a label. So let's add some testing to this. I've also got a package JSON, and that is used to bring in kind of third-party dependencies from JavaScript land. So I brought in 2 things. I brought in this new NPM package, Focus for Innovation, JUCE end-to-end that we use. And I've also brought in Jest, which I'm going to use just to find and run the tests. So if I write a test in here, let's just start with a Mickey Mouse example. Let's check it adds 2 numbers. Okay, so I expect that 1 + 1 to equal 2. Let's see if that works. Otherwise, we're really in trouble here. Okay, there we go. We have a test, and it does work. It adds 2 numbers. But we want to test this actual application, right? So the first thing we need to do is connect to the app, right? So we need to kind of create a connection using this new library. So the way I do that is I create an app connection object, and I bring that in from Focus on Innovation, JUCE end-to-end. I'm also going to need the path to it, so it needs to know where that app is. So I've got that in a little file here. Okay, so rather than checking it adds 2 numbers, let's check that that increment button works. This is going to be an async test. So the first thing I do is create a connection to that object, to the app. So let's say app equals new app connection, and I pass it the path. And let's then launch the app using app.launch, and then shut it down. Okay, let's see if that works. So it runs, and it does launch the app, but it doesn't realize that it's launched it because it hasn't connected to anything. And that's because we haven't modified our app at all yet. So it has no way of connecting back. So let's add that stage now. So I need to make a quick change to my CMake list. So we include CMake support, but you can, it's not essential. You can use anything really. Fetch JUCE end-to-end .cmake. How I called it. Focus on E2E. And then I just need to link to it. Okay. So the way this works is in my application, I just need to add something called a test center, and that's going to bring in everything that I need. So focus on E2E, test center. Let's just copy it because I'm typing with people watching me, and that's going to be a problem, isn't it? So there's a factory function there. Okay. Let's build that, and we'll just wait 30 seconds. So yeah, we wanted to make it so that it doesn't require too many changes to your application. So all you have to do is instantiate one of these things with the factory function, and then the whole app should then be kind of available to test. Let's see how far we get with that. Okay, built it. So now this time when we run our app, so it's worked. So this time we have launched our app and quit it, and we haven't really tested anything. So let's go one step further. So this time what we want to do is click on the increment button and check that that value goes up to 1. So what I'll do is click on the button. So I do that with my app.click component, and then I give it the ID of the button. So let's call it increment. And then I want to get the value from that label. So let's say value equals await app.get component text. Let's call it value. And then I want that value to be 1. Okay, let's see if that works. This should be a string. Okay, so this time it's launched the app and it's tried to click on the component, but it hasn't found it. And that's because we haven't kind of registered that component. There's no way it could know what it is without the ID. So let's make that change. So the way we do this is we include a header called component search. And we just call register component. Which is set test ID. And we pass our increment button. Oops. That's going to be called increment. And we're going to pass our value label called value. So save that. Rebuild it. Okay, so let's see if this test works now. Okay, this time it's failed because it got the value 0 from that text label and it was expecting the value 1. And that's because it doesn't do anything, right? We saw that earlier when we tried it. So let's hook up the button so it actually does something. There we go, so it's worked. So this time we've launched the application, we've clicked on a button, we've got the value from the text label, and we've checked that the value is right, and then we've shut down the app all in one. So let's just take this one step further. I'll just do the decrement button as well, just to kind of show you how this would extend. So we've got our decrement button, and I'll also hook it up as well, so you don't have to wait for me to do that twice. Okay, so for now, I'm just going to copy it. And this time we expect the value to be -1. So let's run that. There we go. So we've run 2 tests there in the space of 1 second. The first one checks that we increment it, and the second one checks that when we decrement it. So let's just tidy this up because we've got some kind of duplicated code there. So there's something called BeforeEach, which I can use to run some code before every test. So we'll launch the app before every test. And we will quit it after each test. There we go. Let's pull that out. And the other thing I'll do is I'll just pull out this function to get the value, because that's duplicated in both of them as well. So we'll have something like expect labeled spec values. There we go. So this time we expect the value to be 1, and in this one we expect it to be -1. Okay, let's see if I broke it in that refactor. Pray for rain. There we go, we're still working. Let's go back to this. Okay, so some of the lessons that we've learned kind of from going through this process. The first one is listen to your tests. So it's tempting when a test fails to blame it on the test or blame it on some fairy dust. But if there's something, for example, if there's something in your startup code that fails 1% of the time, then you're going to occasionally see what looks like random tests failing. And when you rerun them, it will work fine. And you merge it and then move on and pretend it didn't happen. But if there's a problem that affects 1% of your users, or even worse, 1% of the time that your users start your app, that's still hopefully quite a lot of users. So at the very least, you need to keep track of when tests are failing and to try and spot if there's any patterns. And that kind of leads on to the next lesson, which is make sure your continuous integration keeps track of which tests are failing and when, so that you can spot these patterns if there are any. And if it doesn't, then it might be something to consider building on top. The next one is to treat tests like production code. So it's really tempting to treat tests just as this kind of like fun playground where you can just kind of hack things together and make it work. You just copy and paste this from here to here. But I think if you want tests to be a serious part of your infrastructure, then the same rules apply to tests that do to the rest of your app. So you should treat it in the same way. And if technical debt builds up in your tests, if it's really hard to add a new test, for example, then there's just that little bit of inertia that makes it really hard, and someone's just going to not write them when they come along. So the next one is run tests in parallel. We found that when we run these tests, it probably takes about 15 minutes to run maybe 100 tests. So it's only a few seconds to start the app up and shut it down each time, but that can really add up. So if you can, it saves a lot of time to run them in parallel across multiple machines. And the last one is focus on the most important use cases. So end-to-end tests are a very expensive way to test your code. It's very heavyweight to start a whole app just to test a little bit of functionality. So focus end-to-end tests on where you think you'll get the most value. Don't worry about, for example, testing every possible error condition or every possible input to an algorithm. That's something that should be focused down in the unit test level. Focus on what the user is trying to do. So a good rule of thumb is focus on what would be embarrassing if your app stopped doing, and try and kind of aim the tests in those areas. So yeah, that's everything from me. Thanks for your time. There's been quite a lot that I haven't been able to mention from this particular end-to-end solution, but it's been really useful for us, and I really hope it's useful for other people as well. A few links here. So the top one is where you can go to find the code and hopefully some instructions on how to get started, if that is something you're interested in. The next one is where I've put all these slides, if they're useful for you. And that's my email if you want to sign me up for some spam or whatever people do these days. Yeah, thank you very much. Oh, I just got, well, if there are any questions, I'm just going to put on in the background running all of our real tests so you can see what it looks like in a kind of system that's not just a counter.
Truly.
Oh, you can't see that. Let me...
Well, thank you. Truly putting the rest of us to shame with this masterclass in testing. So we've got time for a few audience questions.
Yeah, so I'm just wondering why the need to register components actually, and not just use the component IDs that JUCE has already. Like every component has an ID, and we could just...
As in the name of the component?
Yeah, I mean, there's a component ID as well, right? We have a component name and a component ID.
Right.
JUCE components. So why not just use these and say, like, one register components call, and it just iterates over all components and picks everything and maps it to your system or something.
Yeah, I actually didn't know that was there, so I'm going to try to make up a different reason. But maybe other people might use that ID for something different. But yeah, that's a good idea. Maybe we could look into.
I might be wrong.
I'm not sure if they're guaranteed to be unique, the ideas that you're talking about.
Anyone from the JUCE team?
Yeah, they're not. Yeah.
They don't have to be. They don't have to be unique as well. In this case, there's often quite a few of the same, and you can specify like a wild card, or say pick the 10th one of these, or something like that as well.
Oh, well, yeah, then that makes sense.
Yeah. Dave.
Yeah. I was going to say, where does the biggest time come when you're running the test? You mentioned startup and shutdown was quite a big cost.
Yeah.
Have you looked into, rather than actually shutting down, just kind of wiping the state and starting again, or combining tests so it kind of tests multiple things?
We definitely could. So we're trying to be kind of purist here in trying to start the app and shut it down every time, wipe the cache on disk. So it's, I guess the problem you'll run into is if one test depends on the state of a previous test, then they're going to get harder to detect. Or maybe if something builds up over time, like if you've got a memory leak or something like that, it's going to be harder to spot if you're kind of constantly, if you just leave the app running and just do lots of different tests. But if there was a reliable way to get the app into its startup condition, then that would definitely save a lot of time.
Just one comment on that. I think it is common to do multiple tests, but then randomize the order so you do catch that case, because users will be doing that kind of thing as well.
Yeah.
What do you think would be the best way to adapt this kind of testing framework for audio plugins? Would you use like the JUCE plugin host, or is there a specific way you would go about doing that for people who are making purely plugins?
Yeah, it's a good question. So I guess you get to define what your two ends are in end-to-end testing, right? So you can define what you class as the start and the end. With a plugin, there's sort of a plugin is just a library, right? So it has kind of a clear interface in that respect. So you could say that testing a plugin through that VST interface is actually enough. Or you could say, actually, all the doors handle this interface differently, so we want to test it in a real door. Or you could say, all right, we want it to be hosted inside an application, but we don't mind which one. So maybe you could have your own host, or use the JUCE host, or any of the other kind of like plugin validators that exist. So yeah, there's a few different approaches. It depends what you class as your two ends and how far you want to go with that.
Yeah, I was just wondering, so you say that tests take obviously quite a long time to run. So how frequently are you running them? Are you running them just once release, or do you do nightly builds? Do you run them for specific branches? And then also I'm wondering what you do, like for example, if you were to update JUCE, would you then kind of obviously need to do some sort of regression test, because there might be bugs that are introduced during the update? Not that there are any bugs, but of course there's always a possibility that there may be bugs introduced when you're updating like external libraries and third-party libraries.
So yeah, we run them on everything that gets merged in. So every pull request, it'll run through all 100 odd tests or whatever. Have
you ever run into any issues with that, like clogging up CI pipelines if people are pushing lots of commands?
Yeah. That's why we run them in parallel. Yeah, especially if you make a tiny little change and you're like, oh no, I need to wait for them all. But it's just a kind of choice that we make, that they do find bugs as well. And the kind of bugs that you don't spot in unit tests, like a crash on shutdown, for example, you wouldn't spot that in a unit test. Whereas when you start the app and shut it down every time, you're going to find those kind of things.
You talked about using a dummy audio driver in the CI environment. Have you thought about putting anything in that audio driver to validate the audio data that's being sent?
That's a good point.
About like, actual audio output of your application.
Yeah. So we don't do that right now. It's possible. It would be a good extension to this kind of system that you could request. You say, give me the audio from the last 10 seconds that's come from the app. We generally focus our kind of audio testing at lower levels, so unit and integration, just because of kind of the complexity of running it through a complete app. And the audio system's quite separate, really, so that we have a lot of confidence running them at a lower level in that regard. But it would be a really nice extension to kind of run the whole app and check that if you'd accidentally muted the master output or something like that, you wouldn't spot it.
So once you have a failing test, what does the process of going to fix that look like? Do you just intuitively go, oh, I know what that'll be if I press that one button, or do you have to kind of just run through the test manually and hope that it replicates, or do you have do you take all the crash logs and look at dump files?
So there's a few things we capture from the system. We capture logs from the output in quite a verbose way. We also sometimes, if it's something visual, like, you know, it is expecting something to be visible and it's not, we'll take a screenshot of the whole app so you can see what state it is in. Because usually it's like, oh, there was something covering it, or, you know, there was a modal. And then if you've got a repeatedly failing test, yeah, you would try and run it locally. You can just run that one test and hopefully it'll do the same thing. Sometimes it won't. And then you're just into kind of debugging land. Yeah.
Hello. Hands Online asks, why are you not using C-test when everything is already in CMake?
We do use C-test, but not for these tests. We run them separately. I think just because it's just a single entry point. And then we chose the Node and TypeScript for all those other reasons. We don't want to have to compile our tests for these. But we do use C-test for our unit tests.
How do you choose which end-to-end tests to run? Do you like every time a user files a bug, is that like an end-to-end test?
That's a good time to do it. We try and add them to as we're developing it. And if a user reports a bug that we think is something that we should have had, then we'll try and add it retrospectively. Yeah.
So you mentioned that you open a test socket for testing this. Does that mean that you actually ship the final product with a test socket open, or do you compile different versions and you ship a different version that you actually tested?
So the version we test is the version, you know, it gets tested, and if it's good, then it goes up online straight away. It's just playing some sounds. And in the real, when the user starts it, it doesn't start with that flag. So when we start it on the test, it comes with a different flag on the command line to say, please open a socket to this test server, which the user won't have. So there's kind of basically zero overhead for the user.
I think we've got time for maybe one last question, if anyone has.
Chris Online asks, how do you debug best if a test fails and you want to step into your C++ code?
So it's possible. You just need to, if you set a breakpoint in the test in the JavaScript or TypeScript code, it'll stop at that, and then your app will still be running, and it's still a debug app. So you can just attach to the process, and then you can step through both processes together to kind of work out what's going on. A little bit fiddly, but it's possible.
I've got one quick final one for you. Have you discovered anything surprising? Have you discovered any unexpected bugs that you might not have done before your robo-tester?
Yeah, there's a few things where it just runs it that little bit faster than a user would. So sometimes little timing issues or strange states, like, oh, you deleted it before it got into this state, but a user could never do that. But that's usually actually a bug. It's just, so actually it's harder to get the end-to-end test working than it is to fire up the app and play around with it, because you're being kind of nice to it and being kinder, whereas this goes much faster. So yeah, we found quite a few little bugs like that.